have seen two problems on Fourier transforms. Just continue from that point. Okay, in today's class we will just take up an example. So in which modulus is present. If modulus is present, how do we handle that function? So the method won't be different from whatever we discussed in the last class. So the method will remain the same, formulas will still remain the same, but how we are supposed to analyze the function, so that matters with respect to the modulus. Let me just take up this example. Here the question is to find the Fourier transform. Let me just do that. Find Fourier transform of f of x equal to 1 plus mod x by a. I have taken this from the previous year question papers. Mod x less than or equal to a. Okay, the function value is 1 plus mod x by a if mod x is less than or equal to a, and it is 0 otherwise. Okay, just let me analyze what is given on what should be how we are supposed to analyze this. The basically for question is to find the Fourier transform. If I write the formula, so we know we are computing f of alpha. It refers to what? Fourier transform of this function f of x. It's given by the formula 1 by square root of 2 pi integration minus infinity to plus infinity f of x e power I alpha x dx. Okay, we use the same formula even in last class to find the Fourier transforms. Now, if I consider this function on the real line, let me see what we have exactly. Okay, so this is our left extreme, minus infinity, right extreme, that's plus infinity. Function should be known to us from minus infinity to plus infinity. And how the interval is designed? They are saying mod x less than or equal to a. Okay, what is the meaning of this mod x less than or equal to a? So this means the values of x lies between minus a and plus a. Okay, the meaning of this one is values of x lying between minus a and plus a. So accordingly, if 0 is the midpoint for this interval, we can note that minus a lies towards the negative part and plus a lies towards the positive part, with assuming a is a positive number here. Okay, so which means they are saying that this function is given in the interval minus a to plus a, this is the function, otherwise it is 0. Which means otherwise refers to these two intervals. So in this interval, value of the function is 0. That is from minus infinity to minus a, it is 0. Again from a to infinity. Okay, except this interval, in the remaining two intervals, value of the function is 0. So in this interval, let me just come back to this interval now and see what we have. In this interval, they have given it is 1 plus mod x by a. We know that mod x is minus x. Okay, so mod x is minus x for the values of x in the negative interval. I think you are clear with this. Okay, mod x is giving the positive value. Okay, it becomes a positive value in 0 comma a, and it takes the negative values in the interval minus a comma 0. That is, suppose if the number is minus 2. Okay, minus 2 is, let me assume minus 2 is the number which lies between minus a and 0, and we know that modulus converts that negative number to the positive number. So if I have considered minus 2, to convert that into a positive number, I should take mod x as what? Minus x, so that minus into minus becomes plus 2. So according to that, from minus a to 0 in this interval, okay, in this interval minus a comma 0, and again in the interval 0 comma a. So let me see what the function is. In minus a comma 0, the function is 1 minus x by a, and in the interval 0 comma a, it is 1 plus x by a. I hope it is clear to people. here f of x is taking 1 plus mod x by a from minus a to plus a. In this range or in this domain, x takes negative values as well as positive values. If x is positive, mod x will give us the positive value, so I have written it as 1 plus x by a. But if x is negative, we should convert that negative number to the positive number. Suppose if my x is minus 2, I need to have it as 1 plus 2 by a. So for that, what I am supposed to do, I should write mod x as minus x, so that when you take x as negative number, that minus into minus will give us the positive number back. Okay, which means in minus a comma 0 the function is 1 minus x by a, and in 0 comma a it is 1 plus x by a. Okay, now if we just come back to this integral, so it's 1 by square root of 2 pi, and you can note in this interval the function is 0. Again from here to here it is 0. I am just neglecting that interval, as integration of 0 becomes 0. So from minus a to 0, f of x is given by 1 minus x by a into e power I alpha x dx, plus second integral is, let me write it here itself, plus, just shift it up, plus integration 0 to a. Okay, from here to here, function is given by 1 plus x by a into e power I alpha x dx. Okay, we can note product of two functions here. The remaining part is as usual. So this is my first function u, this is my second function v. Product of two function with first function is polynomial. Again the same thing, polynomial into exponential function. So you people know how to handle this. Let me just make use of Bernoulli's integration to integrate this. Okay, let me just open the square bracket. Let me just write this part first. So u is written as it is, 1 minus x by a into integration of e power I alpha x plus e power I alpha x divided by coefficient of x, which is I alpha, minus differentiation of 1 minus x by a, it's minus 1 by a into integration of e power I alpha x divided by I alpha into I alpha, it's I alpha whole square. Okay, plus differentiation of minus 1 by a becomes 0. Stop the process, substitute the limits, minus a and 0. Now do the same thing with respect to the second interval now. Second integral, so it is 1 plus x by a into integration of e power I alpha x, that's e power I alpha x by I alpha minus 1 by a into e power I alpha x by I alpha whole square. Let's close the bracket, 0 to a. Okay, now let me substitute the limits for this. Okay, so this is equal to 1 by square root 2 pi times, so for the upper limit x is 0, let me just open the bracket. So let me substitute the upper limit for this entire expression. Here I square is there. Okay, I'll just take this I square to this place, and this negative sign also comes here, so totally minus into this becomes plus positive sign, and here this negative sign with this negative sign becomes as positive sign. Okay, so let me just substitute the limits now. So if I substitute the upper limit, x is 0, this just becomes 1, so it is just e power I alpha divided by I alpha. Come to this term, we got 3 negative signs, so it is minus e power I alpha. Okay, I'm substituting the upper limit, sorry, so this should be 0. So x is 0, so e power 0, sorry, yeah, it's e power 0 by I alpha from this expression. From here minus e power 0 again e power 0 by a I square, this is taken this side, so it is just a alpha square, minus, substitute the lower limit for the same expression. When you substitute x is equal to a, minus into minus plus, a by a becomes 1, so it is 1 plus 1, which is 2, e power minus I alpha a divided by I alpha is our first expression. Second one, it is negative sign again, e power minus I alpha a divided by alpha square. Please interrupt me if you get any doubts, if you find it anything you want to ask, so please stop me in between. So for upper limit x equal to a, this becomes 2 times e power I alpha a by I alpha, minus into minus, it becomes plus actually, so it's e power I alpha a divided by a alpha square, minus, now substitute the lower limit, put x equal to 0, with that this becomes, first term becomes 1 into e power 0 by I alpha, and it is plus e power 0 by a alpha square again. Now this is equal to 1 by square root 2 pi. Okay, note that except in this step, in all these steps we are just doing the algebraic work. So it's 1 by I alpha minus 1 by a alpha square minus 2 e power minus I alpha a by I alpha, minus into minus, plus e power minus I alpha a divided by alpha square. Don't we have a in this place? I think we have a here, sorry, let me see, yeah, we have a alpha square, okay, that's right. Let me come to this term now, it is plus 2 e power I alpha a divided by I alpha, and it is plus e power I alpha a divided by a alpha square, and from here it is minus 1 divided by I alpha minus 1 divided by a alpha square. Okay, so this is equal to 1 by square root 2 pi times. If we just check out these expressions, we can note that this term and this term gets cancelled, and remaining terms we can merge. So this becomes minus 2 times, minus 2 by a alpha square, and this is from here, from this term and I alpha, yeah, this term. So from these two terms we can note 2 by I alpha is common, it's plus 2 by I alpha is common, so here e power I alpha a remains, and in this one it is minus e power minus I alpha a remains. So from these two expressions then, okay, from this expression and one more, where is that, yeah, this one. So from these two, 1 by a alpha square is common, so it's 1 by a alpha square is common, so here e I alpha a is remained, and in this one plus e power minus I alpha a is remained. Okay, so this is what the expression we have, and we know that if people know this formula, so cos theta is given by e power I theta plus e power minus I theta divided by 2, and sin theta is given by e power I theta minus e power minus I theta divided by 2i. So by using them, we can just rewrite this expression as 1 by root 2 pi times minus 2 by a alpha square e power I theta minus e power minus I theta. Okay, that gives most 2i times sin theta. So it is plus 2 by I alpha is multiplied to 2i sin alpha a, and in this expression it's 1 by a alpha square into e power I theta plus e power minus I theta is 2 times cos theta, so it is 2 times cos alpha a. So you should keep your answer always in terms of sin and cos. So it's 1, 2 is common here. That 2 is taken out. Okay, I'm just taking this 2 common. This 2 and this 2 and this 2 are taken out. And we know that root 2 whole square is your 2. So 1 root 2 and root 2 cancels. We'll get square root of 2 by pi. Okay, 1 root 2 cancelled. We have got another root 2 divided by root pi. That becomes square root of 2 by pi minus. So this is your just minus 1 by a alpha square. So this term is 2 is taken out. So it is I will get cancelled. Sin alpha a by alpha. And this term is a alpha square is remaining in the denominator. So it is cos alpha a by a alpha square. That's all. This is what your Fourier transformation, and this fails when alpha equal to 0. That's all. Just see what we have done here. So here the important thing is this. Otherwise, so the integration works just similar to your Fourier series problem or the problems which we discussed in the previous class. Here the first thing is, so function is given like this. So they're saying that the value of f of x from minus a to plus a is given by this, otherwise it is 0, which means before minus a it is 0, after plus a it is 0, between minus a and plus a it is given by 1 plus mod x by a. And to convert the negative number to the positive number, so mod x will take the negative value. Okay, mod x becomes negative minus x in the negative part of x, and for the positive values of x it will be taken as plus x. So it's 1 minus x by a, here it is 1 plus x by a. So it is f of x, it is u into v, u into v. In both the cases we just went with Bernoulli's integration, as one of the function is polynomial here. So the remaining part is just the algebraic part. And one more important thing is, we should not keep our answer in terms of exponential function, just to assure that. So we have a finite function, finite value, because we know that sin and cos always gives the value in a definite range. That is, sin and cos value always lies between minus 1 and plus 1. If it is expressed in terms of exponential function, there is a chance of infinity case. So we are just eliminating that, expressing everything in terms of alpha. Okay, yeah, yes, yes, sure, sorry, you are right. So 1 2 is taken out, but 1 2 is still left out here. Yeah, you are right. Thank you. So somebody is attentive here. I'm happy. Thank you. Okay, let me see one problem. So it uses modulus again, but with respect to inverse, we have not seen even a single problem on inverse now. Let me just start with that inverse problem. One problem on inverse. Once again, this is a question paper problem only. I just collected question paper problems and I just kept it in definite order, so that so if things become simple for you people. So if it is in definite order, that's what I've done here. Okay, here the question is, find inverse Fourier transform of, the question is to find the inverse Fourier transformation. Definitely they have given a function of alpha now. So this is equal to e power minus a mod alpha. Okay, and they have set the value of a is greater than 0. Okay, so to find inverse, we know that whenever we find inverse, it will give us a function of x back. And how do we denote that? It's f power minus 1 of f of alpha, which is given by the formula 1 by square root 2 pi integration minus infinity to plus infinity function of alpha, this function should be written here, into e power minus I alpha x d alpha. You are integrating with respect to alpha, and make sure you are written negative sign. For the Fourier transform, you do not have negative sign. For inverse, you have negative sign in this place. Okay, so if we are integrating with respect to alpha, and look at this function, so they are not said the function is given from where to where. When it is not mentioned, by default we will assume that the function is given from minus infinity to plus infinity. Okay, so if the function is given from minus infinity to plus infinity, how this function is designed? Let me just check out that. So this extreme is minus infinity as usual, and this extreme is plus infinity. 0 is the midpoint. So and look at this function. It's a modulus function, and when a function is given in modulus, you people know that. So this becomes what? Positive. We will take mod alpha as negative number. Okay, we will take mod alpha as a negative number for negative values, so that when we multiply that negative number by this negative sign, that will be converted into a positive number. So in this range, that is from minus infinity to 0, the function is given by e power minus a into minus alpha. That becomes e power plus a alpha. And in this range, e power minus a into the mod alpha just remains alpha there. Okay, this is what the actual functions are. So I know the function from minus infinity to plus infinity. So let me substitute that. So 1 by root 2 pi times from minus infinity to 0, function is e power a alpha into e power minus I alpha x or ix alpha d alpha plus from 0 to infinity e power minus a alpha into e power minus ix alpha d alpha. And in this problem, integration part is very simple, because it is product of two exponential functions. We know that when the bases are same, okay, when we have a power m into a power n, we write that one as a power m plus n. So bases are same, add the powers. So it is e power and okay, yeah, a alpha minus ix alpha. So from these two, alpha is common, so a remains in this, minus ix in this expression, alpha d alpha, plus from 0 to infinity, it's e power minus alpha is common here, a plus ix alpha d alpha. Okay, in each integral, it is just integration of e power ax. We know that it is given by e power ax by a. Let me substitute that here. So 1 by root 2 pi. Okay, so it is e power a minus ix alpha divided by coefficient of alpha in this time. So x is the variable in this case. Here alpha is the variable. Write the coefficient of it, which is a minus ax, between the limits minus infinity and 0, plus the same thing again, e power minus of a plus ix alpha divided by coefficient minus of a plus ix between 0 and infinity. So I've told you people already, e power 0 is 1, okay, e power 0 is 1, e power minus infinity tends to 0, e power infinity tends to infinity. Now let me just see the cases what we have here. So integration part is so simple. Substitute the limits. Upper limit e power 0, alpha is 0, so this becomes just e power 0, that's 1 by a minus ix. This is for the upper limit, minus. Substitute the lower limit now. For alpha is minus infinity, this becomes e power minus infinity. E power minus infinity is what? 0. Plus, for the upper limit, it is e power plus infinity, which is, sorry, e power minus infinity again. Okay, so alpha is infinity, so we already have negative sign here, e power minus infinity, which is 0, minus the lower limit, x is, sorry, alpha is 0, this becomes e power 0, which is 1 by minus of a plus ix. It's just 1 by root 2 pi times 1 by a minus ix and this is plus 1 by a plus ix. Just take the LCM and simplify this. 1 by root 2 pi times a minus b, a plus b. That just becomes what? A square minus b square. A square minus b square. And it is a plus ix plus a minus ix. Okay, and you have plus ix minus ix cancelled. So it is 1 by root 2 pi times 2a divided by a square, and I square is minus, so it becomes plus x square. And I can just take the 2 out. So just like the previous example, here it becomes, so square root of 2 by pi times a by a square plus x square. That's all. So the integration part is so simple in this case. Okay, but if you are talking about the same situation here, okay, for example, if I consider okay, I will do one thing. I will just take that example in the later stage. I just wanted to talk about one more problem. I will take that problem itself, and I will discuss that problem in the later stage. Okay, let me consider next case. Okay, so till now we have seen the straightforward problems. The first two problems were very straightforward. In the second two problems, that is in third problem and fourth problem, we took the function which having modulus in it. So in case of modulus, how do we handle that function? How do we analyze the function? That's what we saw. In the next problem, we are going to take up an example which uses this, like problem which uses this particular integral, integration 0 to infinity e power minus x square dx. Actually, I have given this as a note for you people, I feel. Square root pi by 2. Okay, so this actually comes from gamma function. Okay, this comes from gamma functions. Gamma function actually in second semester I was taking this part to people. Okay, so that is gamma of 1 by 2. So gamma of 1 by 2 is square root pi. We proved that in the class. So it actually taken from that result itself. Okay, in few problems we may need to make use of this one. We'll just take up an example of this kind. And this problem which we are discussing now, the fifth problem which I am discussing now, it is taken from the model paper as well. So one of the model paper carries this question. The question is, find Fourier transform of f of x is equal to e power minus a square x square. Okay, problem is very simple. Actually it doesn't we don't use integration as well, so we're just taking the help of this one. But how we are bringing the given integral to this form, so that is what the challenge here is. Let me see how does it works. Okay, find the Fourier transformation of this function where a is a positive constant. So in any of the above examples, in any of the problems under this setting, if the constant is not mentioned, like whether it is a positive number or negative number, in those cases by default we will assume it as a positive number. Okay, a is greater than 0. Here we need to prove that. Hence, we need to show this. Hence, show that e power minus x square by 2 is self-reciprocal. Okay, is self-reciprocal with respect to Fourier transform. Okay, at the end I will explain you what is the meaning of self-reciprocal. We'll come to that. Okay, so first of all we need to find the Fourier transformation of this one. Hence I need to deduce Fourier transformation of e power minus x square by 2, and we will talk about self-reciprocal later. Let me take up let me start with the definition again. Question is to find the Fourier transform, so which means obviously we are finding f of alpha. So which means we are actually finding what? Fourier transform of e power minus a square x square. That is the Fourier transform of the given function. So which is 1 by square root of 2 pi integration minus infinity to plus infinity e power minus a square x square into e power I alpha x dx. So okay, I have not written the definition. First let me write the definition, then I will substitute in it. Okay, it is f of x e power I alpha x dx. And as I told you people in my previous previous problem, this function, for this function they have not mentioned the interval, which means by default we are going to assume that the function is given from minus infinity to plus infinity. Okay, so which means, so this is equal to, so 1 by square root 2 pi integration minus infinity to plus infinity. The function is what? E power minus a square, e power minus a square x square into e power I alpha x dx. This problem is quite similar to the previous problem with respect to the initial part of it. Okay, so once again it's a product of two exponential functions. Since the bases are same, we need to add the powers. Let me do that. Let me write it here itself. 1 by square root 2 pi integration minus infinity to plus infinity e power, in this one I will just take the negative sign out, minus of a square x square. Okay, I will do one thing. I don't take anything common. Let me just write it, just add the power. So minus a square x square plus I alpha x dx. I hope it is clear to people. So bases are same, we just added the powers in it. Okay, so now the challenge is, just now I told you that, so we are interested in making use of this integral. The reason is we can't integrate this function directly. So we need to reduce this integral into the form of e power some minus x square. Okay, so variable is x, e power minus x square dx. I want to bring this expression into this form. So for that we will take the help of the completing the square method. Okay, now let me consider this part. Okay, consider, okay, this part itself is the heart of this problem. Okay, if you understood this part, nothing is there in this. It's a very simple expression. So consider this expression now. Consider minus a square x square plus I alpha x. Okay. So this is equal to, so first this is what we are doing. I will take minus a square common from this one. Okay, I just want to bring completing the square into the picture here. So minus a square is taken out. What left? X square minus is taken common, so it should be minus I alpha x by a square. Okay, so as I mentioned, I want to bring a plus b whole square into the picture, or a minus b whole square in this time. So a minus b whole square is given by what? A square minus 2ab plus b square. So in this expression you are finding x in two places. I want to reduce this into expression containing x only once, like this. In this expression you are finding a at two places, b at two places, but when you complete the square you can note that a and b are you can find a and b at only one place. That's what the basic idea here is. I'm finding x at two places, I just want to have it in only one place. For that, as I mentioned, now we're going for the completing the square. So how do we do this? Let me see. Minus a square times, the role of a is played by x in this case. So it is a square means it is x square for me. Okay, that is written. Minus I want 2ab. So I will write 2 is not present in it. I will just write this 2. And a is nothing but what? X. I have x here. I will just write this x as it is. Now write what is remaining. I alpha is not used. Write it by a square. And 2 I just brought it into the picture just like that. So I just need to cancel that. I just need to balance between this expression, this expression. I will write 2 in this place. Now this 2 and 2 will get cancelled, so that I will get I alpha x by a square. So I expressed this expression in the form of 2ab with a is x. So which means b is obviously what? I alpha by 2a square. So let me add I alpha by, let me add this b square and subtract b square from it. Which means it is I alpha by 2a square whole square, okay, minus I alpha by 2a square whole square. Okay, a square minus 2ab plus b square. So this expression, okay, this expression will give us, it is same as this expression. Okay, it is same as this expression for me now. So accordingly, this becomes minus a square times a minus b. So a is x minus b refers to I alpha by 2a square whole square, a minus b whole square, a minus b whole square minus, but you have I square here, that will make it plus alpha square by 2 2s are 4, so 2 square is 4, a square whole square is a power 4. Now let me multiply minus a square inside. This becomes what? Minus a square into x minus I alpha by 2a square whole square and minus alpha square divided by 4a square. Okay, so just see what we have done. So this itself is heart of this problem. If you are thorough with this, nothing else is there in this. It's very simple. Okay, what I did here first, I just wanted to have x in only one place. As I mentioned, I just taken minus a square common from this, so it becomes x square. Minus a square is taken out, so it should be plus, should become minus. A square should come to the denominator. I alpha x is written as it is. This is my a square, and I want to write it in the form of 2ab. So 2, the role of a is played by x, so that is 2a, and write the remaining part of it. The remaining part is I alpha by a square, and to balance it I need to have 2 in the denominator. This is my b, a square minus 2ab, add b square, subtract b square. Now this becomes a minus b whole square plus square of this one is alpha square by 4a over 4. Multiply minus a square inside, you have this expression. Let me just go for one more step. I will write here minus, I will just take this expression inside, just a into x minus I alpha by 2a square whole square. Okay, so this is my a square into b square. A square into b square becomes what? ab whole square minus alpha square by 4a square. Simple. So what I did here, I wrote this power in this form. Let me substitute this expression back here. So my expression is equal to, this is equal to 1 by root 2 pi times integration minus infinity to plus infinity e power, in the power let me write this expression, okay, minus a times x minus I alpha by 2a square this whole square minus alpha square by 4a square into dx. And observe this carefully. So this is basically what? This is basically e power this expression, okay, so e power this expression minus this expression. It's in the form a power minus m minus n. Okay, that can be written as a power minus m into a power minus n. And what I'm doing here, we are integrating with respect to x. So e power minus alpha square by Fourier square. Okay, this is product of two function, e power this function into e power this function, and this is free from x, so it becomes a constant. So I can rewrite this one as 1 by root 2 pi times e power minus alpha square by Fourier square into integration minus infinity to plus infinity e power minus of a into x minus I alpha by 2a square whole square dx. Okay, see, if you are feeling integration or differentiation is tough, you need not to worry. In this problem I have not done integration till now, so it's just an algebraic work I am doing, just a theory of indices and just an algebraic work of completing the square we have done. Okay, now in this expression, so as I told you, I need to bring this into which form? E power minus x square form. For that, what I will do now, I will just call this expression as, some t. Okay, let we assume a into x minus I alpha by 2a square. Let me call this one as some t. Differentiate with respect to t. This becomes what? A into x becomes dx and I alpha by 2a square is a constant which is equal to dt, which means dx is dt by a. Okay, such a complicated expression. With this substitution, see what happens to this. Square root of 2 pi e power minus alpha square by Fourier square into integration minus infinity to plus infinity. With this substitution, there is no change in the limit. Limit remains same. Okay, as x tends to minus infinity, t also tends to minus infinity. As x tends to plus infinity, t also tends to infinity. There is no change in the limit. And look at this one, it is just e power minus t square and dx is dt by a. And definitely you people have used this result in Fourier series again and again many times. This is integration minus a to a. So pi of x dx, this is 2 times integration 0 to a. Let me just write it down. Okay, so 0 to a pi of x dx. Under which condition? Pi of minus x is pi of x. That says the function is what? Function is even. So 0 if pi of minus x equal to minus pi of x. Under this function is called as what? So under this case, function is called as odd function. So minus a to a pi of x dx is 2 times 0 to a pi of x dx if the function is even. Look at this e power minus t square. If you replace t by minus t in this, there is no change in the function. The function doesn't alter, it remains same. So it's an even function. Okay, this e power minus t square is even function. The limits minus infinity and plus infinity. So what happens to this one? It's 1 by root 2 pi. And when you are writing in the exam, there is no need to write this expression. You are just saying this is an even function. E power minus t square is an even function. As it is given from minus infinity to plus infinity, the value of the integral should be 2 times 0 to infinity function of x dx. So this time it is in terms of t. So 1 by a, let me just keep this constant out, e power minus alpha square by Fourier square into 2 times integration 0 to infinity e power minus t square dt. And we know the value of this integral, and value of this integral is given by what? Square root pi divided by 2. Let me substitute that. So it is, so 2, let me just let it be there. So a square root of 2 pi e power minus alpha square by Fourier square into 2 into value of this is square root pi by 2. See, in this problem we have not done the integration even in a single step. Okay, so but we are actually reducing the integral to the standard form with the substitutions and completing the square method, and we substituted the value of this integral, and the value of this 2 and 2 will get cancelled, this root pi and root pi will get cancelled, so we will just end up with 1 by a square root 2 e power minus alpha square by Fourier square. That's all. Okay, let me just repeat it once. Function is, they have not mentioned the domain, which means by default we will take it from minus infinity to plus infinity. Product of two exponential functions, add the powers. And in this expression x is placed at 2 places, so I can't make use of the substitution to handle this. So I will use the completing the square to bring that x to only one place, like this. Okay, so in completing the square, what I have done, I have just taken minus a square out. So x square minus I alpha x by a square remains. This is my a square minus 2, a is x. Whatever remains now after writing this 2x, that is my b. Add b square, subtract b square. This becomes a minus b whole square. Plus I square becomes plus, this minus into this, plus alpha square by 4 a power 4. Multiply this minus a square inside. We have this expression, and substitute this expression in its respective place. And you can note that here it is of the form a power minus m minus n. From the theory of indices, it is a power minus m into a power minus n. But you can note that the second part is free from x. It's pure function of alpha. We can keep it outside the integral sign. Now integrate this expression. Sorry, we are not integrating this one. Instead, we are going for substitution for this. What is the substitution we have taken? We called this expression as t, so that this becomes e power minus t square for me. With this substitution, dx became dt by a. Since the integration is from minus a to a, if the integrand is odd, the value of this integral is 0. If the integrand is even, value of the integral is 2 times 0 to infinity. And we note that value of this expression is square root pi by 2. So 2 cancels, root pi cancels, the answer is this. So what we actually found here, we found Fourier transform of e power minus a square x square. Okay, so we got this answer. Okay, so now let me just go further. The problem demanded us to do something more than this, that is, show that e power minus x square by 2 is self-reciprocal with respect to the Fourier transform. The question is, actually the actual question is, find the Fourier transformation of e power minus x square by 2 from this. We need to reduce that first, and that will give us some expression. We will see what happens to that. Okay, I want to have e power minus x square by 2 in this place. So I need to go with this substitution. I just need to put a square is equal to 1 by 2 or a equal to minus 1 by root 2 in this. Okay, if I substitute in this expression, see what happens to this one. This becomes Fourier transform of e power minus x square by 2. See what happens to the RHS now. It's 1 by a is 1, sorry, it's plus 1 by root 2, sorry, it is not minus. Okay, so it is a is 1 by root 2, it's 1 by root 2 into root 2, okay, to e power minus alpha square by 4, a square is 1 by 2. So root 2 cancels. There is just 1. This becomes e power minus alpha square by 2. Look at this function. We found Fourier transform of e power minus x square by 2 and function remained same. There is no change in your output. Your output remains same, but it is written in terms of the other variable alpha. Only that is the difference. So such kind of functions, for such functions we say that function is self-reciprocal with respect to the Fourier transform. That is, Fourier transform and its inverse both are same. If you find the Fourier transformation of this one, it's e power minus alpha square by 2. If you find the inverse Fourier of this one, it will give us e power minus x square by 2. There is no change in the function. Transformation is actually not altering the function. So if that is the case, we say that function is self-reciprocal with respect to the transformation. That's all. Okay, it's one of the important question. As I mentioned, it is from the model paper as well. If anybody has doubts, we can discuss that. Okay, and I will send you the notes to you people, and you will find similar kind of questions in the notes as well. You people can definitely manage them. So with this basic idea, whatever I am giving now, people can manage. And I am just touching all possible problems. So from my part, and people can definitely manage with my notes. Okay, so I hope no doubts here. Let me just move to the next question then. Okay, let me take this question, and this is the most common question. I want you people to learn this for sure. So these questions will be part of our almost every model paper. That is, so solving an integral equation. That is, let me see what is the meaning of this. Question number 6, I feel. Solve the following integral equation. Okay, so what is the meaning of this? Let me see. This is solve the following integral equation. Integration 0 to infinity f of x cos alpha x dx. This is equal to 1 minus alpha for 0 less than or equal to alpha less than or equal to 1, and 0 for alpha greater than 1. Okay, and the question continues. So all this integral equation, and further in this problem, normally it won't be the part of this deduction part won't be part of every question. So in few questions you will see this, and I've taken the extreme case. Okay, so with this I'm just discussing all the possibilities with respect to problems of this kind. Okay, we need to solve this equation first. Next we need to deduce. Okay, hence show that integration 0 to infinity 1 minus cos x by x square dx equal to integration 0 to infinity sin square t by t square dt equal to pi by 2. So value of this integral or this integral is pi by 2. Through this example we are establishing that. That's all. So this is something which is known fact. Once again it's a known fact. We are establishing that through this example. Okay. So if you just observe this expression carefully. So I have told you people already, solving an equation means, okay, solving an equation. Means finding unknown. Finding unknown. Unknown is always a function. Unknown or a function. So in this example, solving the equation means finding the value of f of x in it. Okay, solving an equation means in this problem here we should find f of x. Okay, just observe this expression carefully. If you remember, if I just multiply this expression by square root of 2 by pi, okay, if I just multiply it by square root of 2 by pi, we'll get square root of 2 by pi integration 0 to infinity f of x cos alpha x dx. That is nothing but, okay, that expression is nothing but Fourier cosine transform. Okay, let me just consider the equation. Okay, so consider integration 0 to infinity f of x cos alpha x dx. This is given. This is equal to what the question here is. Okay, it is equal to 1 minus alpha for 0 less than or equal to alpha less than or equal to 1, and 0 for alpha greater than 1. And please check out your definition of Fourier cosine transform, which is given by square root of 2 by pi integration 0 to infinity f of x cos alpha x dx, which is equal to square root of 2 by pi 1 minus alpha for 0 less than or equal to alpha less than or equal to 1, and 0 for alpha greater than 1. Now this left hand side represents Fourier cosine transformation of f of x. Okay, otherwise let me just put it like this. This represents Fourier cosine transform of f of x. How do we denote that one? Denote it as fc of alpha, which is given by this expression. Square root of 2 by pi into this expression means it is square root of 2 by pi into 1 minus alpha from alpha value from 0 to 1, and square root of 2 by pi into 0 is 0 for alpha greater than 1. Okay, see, which means, okay, let me just write it here. In this example, this problem is same as find inverse Fourier cosine transform of f of alpha, fc of alpha, of fc of alpha equal to square root of 2 by pi times 1 minus alpha 0 less than or equal to alpha less than or equal to 1, 0 for alpha greater than 1. Okay, so there is no difference between these two problems. They have given the same problem. Instead of asking you to find inverse Fourier cosine transformation of this function by giving fc of alpha, they have asked you to find f of x from this. We know that when we find inverse of a transformation, that will give us f of x back. So to find inverse, they are supposed to give fc of alpha. To find transform, they are supposed to give f of x. In this problem, instead of asking you the problem in this way, it is a straightforward problem. The question is very straightforward. Find the inverse Fourier cosine transformation of this. Instead of asking you like this, they have asked the same question in indirect form. Here the question is to find f of x if integration 0 to infinity f of x cos alpha x is this, which is same as what? Fc of alpha is equal to this. Find f of x from this one. Okay, so let me do this. So fc of f of x is known. Let me call this one as equation number 1. Now we will write take inverse Fourier cosine transform of your equation number 1. That will give us f of x. So I am finding f of x, which is given by square root of 2 by pi integration 0 to infinity fc of alpha into cos x alpha d alpha. I am supposed to integrate with respect to alpha so that I will get a function of x. So, and how this function is designed? Okay, it is square root of 2 by pi times. So from 0 to 1, the function is given by square root of 2 by pi into 1 minus alpha cos x alpha d alpha, plus from 1 to infinity, function is given by 0. Okay, so value of this integral becomes 0. Leave that. We just need to concentrate on this part. Have a look at this expression. We are integrating with respect to what? Alpha. It's a product of two functions, 1 minus alpha, which is u. Cos x alpha is my v. And square root of 2 by pi, which is a constant, let me keep it out. Which is square root of 2 by pi into square root of 2 by pi just becomes what? 2 by pi. Let's open the bracket. It is u into v, and we are integrating with respect to alpha. Keep this in mind. The role of alpha is played by x now. X is a constant for this integration. So it is 1 minus alpha, okay, into integration of cos is what? Sin x alpha by x. It's very, very important. We are integrating with respect to alpha. X is constant, that should come to the denominator. Minus differentiation of 1 minus alpha with respect to alpha, which is minus 1. Differentiation of 1 is 0. Differentiation of minus alpha is minus 1. Into integration of sine, which is minus cos x alpha by x into x, becomes x squared. And differentiation of minus 1 becomes 0. Stop the process, substitute the limits 0 and 1. See, there is no change in the integration formulas. You are still dealing with the Bernoulli's integration. You practice n number of problems under Fourier series with respect to this, so it should be simple for you. Now let me substitute the limits. So this is what the common mistake that we do. So make sure that you are substituting for alpha only. As we integrate with respect to alpha, substitute for alpha. For the upper limit, okay, let me substitute the upper limit for this entire expression. Put alpha equal to 1, this becomes 0. Minus into minus into minus, that becomes minus. Put x alpha equal to 1, that gives cos x by x square. Minus, substitute the lower limit, alpha equal to 0. With alpha is 0, sin 0 becomes 0. Let's mark it 0. So though it is not 0, sin 0 becomes 0. This is minus. Here if you put alpha equal to 0, this becomes cos 0. Okay, cos 0 by x square. Okay, this is 3 negative signs. It's done. So it is 2 by pi times it's minus cos x by x square minus into minus plus 1 by x square. So it is 2 by pi times, what is the answer? 1 minus cos x by x square. Okay, so what is the meaning of this? Here the question is, what should be the value of f of x? Okay, what should be your f of x so that value of this integral becomes this expression? So now we have found that f of x. We are saying that if I substitute this f of x, okay, if I substitute f of x in this expression on integration, we will end up with this answer. Okay, so the question is not ended there, so we need to prove it something from that point. Okay, so here in the place of this f of x cos alpha x, we are finding this 1 minus cos x by x square. Okay, now let me substitute that expression back in equation number 1. Okay, this is done. Okay, this part is done for the deduction part. Okay, so first part of the problem is done. Let me look into the deduction part. See what should be done for the deduction. So for deduction, I should start from substituting that in equation number 1. Okay, or use this f of x in given equation. Let me do that. Okay, so that what do we get? Integration 0 to infinity f of x is 2 by pi times 1 minus cos x by x square into cos alpha x dx into cos alpha x dx, that is equal to 1 minus alpha for 0 less than or equal to alpha less than or equal to 1 and 0 for alpha greater than 1. Okay, simplify this. So this gives us 2 by pi is taken out, that is integration 0 to infinity 1 minus cos x by x square into cos alpha x dx, which is equal to, so 2 by pi is taken out and by cross multiplication pi comes to numerator, 2 is in the denominator, it's 1 minus alpha for 0 less than or equal to alpha less than or equal to 1 and 0 for alpha greater than 1. Okay, so this is what we have, and look at my requirement. My requirement is this. Let me just copy this, copy and paste it here so that we can just see what we want here. Yes. So now in this expression I just want 1 minus cos x by x square, I don't want cos alpha x. So I cannot substitute for x. If I substitute for x, even this will vanish. So I need to substitute for alpha in such a way that this cos becomes 1, so that you will get 1 minus cos x by x square. Then what I am supposed to do, I need to put alpha equal to 0 in it, so that cos 0 becomes 1. Okay, let me do that. So it will give us integration 0 to infinity 1 minus cos x by x square. Okay, so this is equal to pi by 2 times cos 0. So alpha is 0. Alpha equal to 0 lies in which interval? Okay, here alpha equal to 0 lies in this interval. And correspondingly, what happens to this function? If I put alpha equal to 0 in this will give us 1 minus alpha is 0. It's 1 minus 0, which means it is pi by 2. So this is what they are supposed to. The question is 2. Integration 0 to infinity 1 minus cos x by x square dx should be proved as pi by 2. We have done it. Question is not attended. We need to put it in this form. Okay, now the question is, so we got the answer of this one already, which is pi by 2. So, and we are further saying that these two are equal, which means that I need to do few modification in this one, so that it will be, so that this will reduce this to sin square t by t square form. Now let me see what can be done here. A simple task again. So you have sin square theta. What is sin square theta? Sin square theta is 1 minus cos 2 theta by 2. But what do we have here? We have just x. So put 2 theta equal to x in it. What does it give us? Sin square theta is x by 2. Sin square x by 2 equal to 1 minus cos x by 2. So bring this 2 to the other side. So it becomes 1 minus cos x is 2 sin square x by 2. Let me substitute that here. So this will give us integration 0 to infinity 1 minus cos x is 2 sin square x by 2 by x square dx, which is pi by 2. But the thing is, this is not my requirement. I just want t. Just go for the same substitution now. Put x by 2. X by 2 as t. This will give us what? X is equal to 2t. This becomes dx is equal to 2 dt. Okay, and there is no change in the limit again. If x equal to 0, t is also 0. If x is infinity, t is also infinity. So this becomes integration 0 to infinity. So 2 times sine square t, is sine square t divided by x square is what? 2t whole square, 2t whole square, and dx is what? Dx is 2 dt, which is equal to 5 by 2. Okay, let me just move it down. Yes, you can note you have your answer now. So this 2 and 2 will get cancelled with 1 2 square here. So your answer is integration 0 to infinity sine square t by t square dt equal to 5 by 2. That's all. That is what the requirement in this case. See what we have done here. This problem has got two parts. The first part is finding the value of f of x, for which value of this integral becomes this, which means they have given actually Fourier cosine transformation, so which is nothing but this expression, that is just by multiplying square root of 2 by pi on both the sides. Left hand side becomes your fc of alpha, okay, and right hand side is your value of that fc of alpha, which is same as asking you to find inverse Fourier cosine transformation of this function. So for that I should find f of x, which is equal to square root of 2 by pi integration 0 to infinity fc of alpha cos alpha x d alpha. Substitute the function from 0 to 1, it is 1 minus square root of 2 by pi 1 minus alpha. From 1 onwards it is 0. Integrate it by Bernoulli's integration and substitute the limits. It will give us f of x. So this is the value of x for which so value of this integral becomes this expression. Further we need to prove this thing. For that what I am supposed to do, substitute your f of x back in this place and see in what way you can reduce this integral into the required form. So what I did here, I just substituted f of x in this place and I found that this is what the expression is, and with alpha equal to 0 this reduces to the required integral. Alpha equal to 0 on the left hand side is fine. In the right hand side, if I take alpha equal to 0, that is part of this interval, and the corresponding function is 1 minus alpha. So this will give us 1 minus 0. So right hand side is just pi by 2. And this proves the first part of it. Further we need to show 1 minus cos x by x square is same as sin square t by t square. It is pure and algebraic work. It's pure and trigonometric work. Sin square theta is 1 minus cos 2 theta by 2, which means 1 minus cos x by 2 is nothing but sin square x by 2. That is what I have written here. But we don't want x by 2 in this place, I just want t. I am going with the same substitution, x by 2 equal to t. That will give us sin square t 2 and dx is 2 dt and x square is 4t square. This 4 will cancel with this 2 and 2. It will just give us sin square t by t square dt equal to pi by 2. So this was the required integral here. Okay, so please, it has got two parts. Your question need not to contain this second part, that is showing this part. If the question is just to solve this integral equation, we just find f of x and leave it. If the question is to show something, in that case to show that you are taking the help of the given equation itself. That's all. Simple, and it is not straightforward question. So though instead of asking you to find the inverse, the question is given in a different way. That's all. Okay, so today I just want to discuss one more question. So before winding up for today's class, we'll just see one problem and it's enough for today's class. Okay, so hardly how many problems we have discussed till now? We have seen 3 problems. We'll just see one last problem for today's class. I'm going very slowly. I hope it's useful to people. Okay, and I'll send you the notes as well. Please go through it. Question number 7. Okay, this is the most common question that people will see. If you just check out the previous year question papers, you will find this question in at least in every alternate paper. Find Fourier transform of f of x, which is 1 for mod x less than or equal to a, and 0 for mod x greater than a, where a is a positive constant. Hence, evaluate. Okay, the first one, simple problem, integration minus infinity to plus infinity sin ax into cos alpha x by x dx. Integration 0 to infinity sin ax by x dx. Okay, see, so whenever the question is to reduce something, we will use both transformation and its inverse. Problem which uses both transformation and its inverse. Okay, we'll use both, just like the previous example. Even in the previous example, we used both transformation and its inverse Fourier transformation for the reduction part. In general, you just keep it in mind. Whenever the question is to evaluate something or deduce something after finding the Fourier transformation or finding the inverse, in those problems you should use Fourier transformation as well as its inverse for the reduction part. Okay, let me see how does it works. Initial part, question is to find the Fourier transform. So f of alpha is 1 by root 2 pi. I have not separated the problem on cosine transformation and the Fourier transformation. I'm just doing all the problems together, but I'm just going with the difficulty level and the problems of similar kind are discussed together. Okay, so integration minus infinity to plus infinity, as the question is to find Fourier transform f of x e power I alpha x dx. Very simple problem we have considered here, and because it just look at this function, it's minus infinity and its right extreme infinity, and mod x less than or equal to a means you know it is from minus a to plus a. Okay, and the function is given by just 1, so in this range the function is 1, and mod x greater than a refers to the values of x less than minus a and the values of x greater than a. Okay, so this means x less than minus a and x greater than a. So which means in this interval it is 0, a is 0, which means I need to integrate only in this interval, and the value of function is just 1. It's 1 by root 2 pi integration minus 1 to plus 1, sorry, minus a to plus a, as in this interval function is 0, value of the integral becomes 0. Function is 1 e power I alpha x dx. That is just a simple integration. 1 by root 2 pi integration of e power I alpha x is e power I alpha x by I alpha between minus a and plus a. Substitute the limits. For the upper limit, e power I alpha a by I alpha, as the lower limit, e power minus I alpha a, x is minus a. Okay, so divided by I alpha. So I alpha is taken common, 1 by square root 2 pi into 1 by I alpha is taken common, that is e power I alpha a minus e power minus I alpha a. I hope you people remember the exponential function Let me write it again. Sin theta is e power I theta minus e power minus I theta divided by 2i. As I mentioned, we are not writing our answer in terms of exponential function. We are just keeping it in terms of trigonometric. It's 1 by root 2 pi, 1 by I alpha. This is nothing but 2i sin e alpha. Okay, so 2i. Here I and I will get cancelled. 1 root 2 will get cancelled. So it will give us square root of 2 by pi sin a alpha divided by alpha. So simple. Okay, so this is your Fourier transform. F of alpha equal to this. If the question is to find the Fourier transformation, we will do only this much. Done. Problem is to reduce something. This is what I told you people. Whenever the question is to reduce something after the finding Fourier transformation or deduce something after finding inverse Fourier transformation, do the opposite task. So we have found the Fourier transformation. Now consider the inverse of it. So that will help us in evaluating these integrals. Let me write that one. So take inverse Fourier transform of f of alpha. So this will give us what? This will give us f of x. Okay, f of x, which is equal to square root of 2 by pi integration minus infinity to plus infinity function f of alpha e power minus I alpha x d alpha. See, this part is so simple. Just have a look at this. It is square root of 2 by pi integration minus infinity to plus infinity. Let me substitute these values as well. F of x is what? F of x is the given function. This is what my f of x is. Okay, let me just keep it as it is. In my next step I will substitute f of x. Here I will substitute f of alpha. F of alpha is what? Square root of 2 by pi e power minus I alpha x d alpha. Okay, sorry, just wait a minute. Square root of 2 by pi sin a alpha by alpha e power minus I alpha x d alpha. Okay, let me just take square root of 2 by pi outside. That becomes what? 2 by pi integration minus infinity to plus infinity sin a alpha by alpha. And what is e power minus I theta is? Cos theta minus I sin theta. So cos x alpha minus I sin x alpha. Okay, d alpha, which is equal to f of x. In this step I will substitute this function function f of x. So before that it is integration minus infinity to plus infinity. Let me rewrite this one as sum of two integrals. Sin a alpha cos x alpha by alpha d alpha minus I. Okay, I'm just multiplying this expression to this and I'm writing that expression now. Integration minus infinity to plus infinity sin a alpha sin x alpha by alpha d alpha, which is equal to pi by 2 is taken to the other side of x. Okay, and just have a look at this integrand. Okay, this integrand and this integrand, just observe them carefully. And this is what I'm supposed to do now. Here this is, just observe this. I'm replacing alpha by minus alpha. Okay, replace alpha by minus alpha and see what happens. This will give us one negative sign. Sin of minus theta is minus sin theta. Cos of minus theta is plus cos theta. How many negative signs are there here? Two negative signs. So this integrand becomes given function. Limits are from minus infinity to plus infinity. In every problem with minus a to plus a limits, you can check whether the integrand is even or odd. If any one of this condition is satisfied, the things becomes very simple for us. You are also doing the same thing. Just replace alpha by minus alpha and see what happens. This will give us one negative sign. Sine of minus theta gives another negative sign. Sine of minus theta also gives the negative sign. We totally have the three negative signs, so this becomes odd function for us. So value of the second integral is 0, and the first integral I'm just keeping it as it is, integration minus infinity to plus infinity sine a alpha cos x alpha by alpha d alpha, which is equal to pi by 2 f of x. Let me substitute the value of f of x now. F of x is what? The given function. This is our f of x, which is 1 for mod x less than or equal to a and 0 for mod x greater than a. So this is what the value of this first integral. Okay, so this is what the value of the first integral. But you can note that in this expression, okay, let me just copy it down so that you can just observe them carefully. Okay, let me just copy it and paste it down so that we can just compare those two integrals. I'll paste it here. Just compare them. What can be seen here? Wherever you are finding alpha, in those places in my required integral we have x. So here alpha, wherever you will find alpha, you have got x here. I will just go with that small change in it. I will just interchange x and alpha in it. I will just go for interchanging x and alpha, and it doesn't make any difference because we are dealing with what? Definite integral. It is minus infinity to plus infinity sine ax cos x alpha divided by x d alpha becomes dx, which is equal to pi by 2 times 1, and this becomes what? Mod alpha less than or equal to a and 0 for mod alpha greater than a. When you are doing this, you are not only doing in the left hand side, in the entire expression you are doing this. So we got this value now. Okay, so this is what the value of this integral. Okay, that's fine. Now what is the value of the second integral? Okay, just 2 minutes, so we are done with this. Copy, and this is the most common and very important question, so please be with me and see what happens here. Okay, look at this one. We just compare these two integrals. So this is what my requirement is. This is what the integral I have. Minus infinity to plus infinity. Here I have got 0 to infinity. So what should be done? The first part is very, very clear. We just need to make it as what? You just need to okay, so this is basically what? An even function. Since it is even, okay, we already checked with it's an even function. So this becomes what? 2 times integration 0 to infinity sine ax into cos x alpha divided by x dx is equal to pi by 2 into 1 for mod alpha less than or equal to a and 0 for mod alpha greater than a. Just wait a minute. Do we have 2 by pi here? Right, so square root of 2 by pi, that is right. And take inverse Fourier. Oh, I'm sorry. So this is where we have gone wrong. I'm sorry. So this time nobody thought about this. Okay, so it is 1 by root 2 pi, right? So we are finding inverse Fourier transformation. It's 1 by root 2 pi. So it's just 1 by root 2 pi. So this root 2 and root 2 will get cancelled. Okay, here it is not 1 by 2 pi. It should be just 1 by pi. Okay, so this just becomes pi for us, pi into f of x. Okay, so and this is just pi f of x. So value of this integral is this. So pi times this expression. Now it became 2 times integration of this. here I just need to make, just like the previous example, I just want this integral. I can't substitute for a or x, that will alter this expression. I just want to alter only this one, which means I need to choose for alpha. I will just go for choosing that alpha equal to 0, that makes cos 1, and with this alpha equal to 0, that is 0 is the midpoint of this interval, so which means a corresponding function should be used. So it is 2 times integration 0 to infinity sin ax by x dx, which is pi into 1. So the answer is integration 0 to infinity sin ax by x dx is equal to pi by 2. That's all. Okay, so this is what the required integral, this is what the required answer is. Okay. Okay, and this much is enough for today's class. So in next class we will discuss, I just need to spend just one to 1.5 hour is enough for us. So not even 1.5 hour. So I think probably 1 hour is enough. At the max I may need to extend it for 10 to 15 minutes, so more than that one. Okay, let me see what can be done in the next class. So for today's class it's enough. So if you have any doubts we can discuss that part, otherwise we'll stop this class.